In section 9.4, we are doing two things. We are simplifying algebraic fractions, like what the problem you see on the screen. And in a little bit, we will be multiplying and dividing fractions. But the common theme that's going to run through much of what you're going to do on tonight's assignment is you really need to be able to factor, because it is through factoring that we're able to do the simplification that is being asked for in these problems. So 1 through 6 will look something like this, and also problems 19 and 20. We could include those, the last two problems on the assignment. But basically it amounts to this. We are going to write this fraction, this algebraic fraction, in a factored form. Okay, so hopefully you understand that the numerator factors as x minus 8 times x plus 2, and the denominator would factor as x plus 3 times x plus 2. Okay, so the great thing about factoring is it is from these factors that we are able to cancel or simplify, or maybe you can think of the word reduce. And my final answer to the simplify part of this problem is whatever doesn't cancel, x minus 8 over x plus 3. All right. Somebody asked today, can I cancel the x's? And the answer is no. Remember, you can cancel factors, but you cannot cancel terms. These are individual terms, part of a binomial. You cannot cancel those individual terms. Okay, so part one of my answer is to simplify, and there's that answer. Now, what does it mean to state restrictions? Well, we've been doing this quite a bit from time to time throughout the year. I'm looking for those numbers that if we plugged numbers in for these x's in the denominator, it would cause the entire denominator to become 0. So basically, I have to limit what x would be in order to prevent dividing by 0. All right. Well, one of them hopefully is pretty obvious. I cannot let x be negative 3. That would cause 0 here. Well, and some people get a little crossed up because you notice how we've canceled, and some people will make the mistake of not looking for restrictions where they have already canceled. But you actually do need to include whatever was canceled when you are looking for restrictions. Okay, that's very important. So for that reason, you might want to hold off on doing all of your canceling until you've already found your restrictions. And then you can cancel, because for some reason by canceling this x plus 2, it causes some people to think, well, I don't need to consider that as part of my restriction, but you actually do. All right, so there's the complete answer for this problem. All right. When you get down to problems 7 through 12, now you're going to be multiplying two fractions together. And I've just provided a little note for you. Let's see if we can do some canceling. When you learned about multiplying fractions years ago, you were told that it is sometimes possible to cancel between, we're going this way diagonally, or this way diagonally, or you could cancel within a fraction vertically. You just are not able to cancel going from denominator to denominator or numerator to numerator horizontally. Well, before we start seeing if we can cancel, we need once again to get this in its factored form. All right, so when we factor the numerator, we get 3 times the quantity x minus 2. Factoring the denominator, we get 5 times the quantity x minus 4, just factoring out GCFs in both cases. This numerator is prime, it doesn't factor, but this denominator, 5 times x minus 2. Okay, so we'll just mark these old denominators out, and we'll stick with the factored versions. And now it becomes easier to see that we do have some opportunities to cancel. For example, I can cancel going this way. Diagonally, I can cancel those binomials x minus 2. I'm not seeing anything else that does cancel, so this would be my answer to the multiplication part of the directions. I will have 3 times x minus 8. That's just multiplying straight across the top. And the denominator will be 5 times 5, which is 25 times the quantity x minus 4. Now, I'm going to say that for this assignment, it's okay to leave your answers in this factored form. In other words, you do not have to use the distributive property to multiply this out. So save yourself a little bit of time. Okay, well, we've done the multiply. Now let's see if we have any restrictions. Well, once again, restrictions come from the denominators. In this case, we have 2 denominators. So I'm looking here, and I notice that I cannot let x be 4. And once again, even though I've marked this out, I still need to consider it when I look for restrictions. I cannot let x become 2 because that would cause division by 0, which is not allowed. So here is my final answer, including restrictions. Okay, 13 through 18, the instructions will change a little bit, and you're going to be asked to divide. Well, years ago, again, when you were first introduced to dividing fractions, you were hopefully taught that dividing by a fraction means that you must change division to multiplication, and you must invert, or I've used the word flip, the second fraction. Okay, so you invert and then multiply. And then once again, let's see if we can cancel. Or in this case, if you want, you could go ahead and multiply first and then cancel. But in class today, we just chose to go ahead and cancel first. So going this way, remember, canceling is just another way of saying I'm going to divide both of these terms by the same common denominator. And that would be 6x squared. So if I divide 6x squared into itself, that would leave me with 1. And if I divide 6x squared into 12x to the 4th, that would be 2x squared. Okay, going this way, I notice that I can divide y into both of these. Y into itself is just 1, and y into y cubed is y squared. Okay, so let's multiply straight across. 1 times y squared, and straight across 1 times 2x squared. And there's the answer to the division. Now, when it comes to finding restrictions for division problems, you notice that here I have x on the top, y on the bottom, but when I changed it, they switched places. So you kind of have to be careful. It really doesn't change my answer in this particular case, but in this case, I've got both x and y that cannot be 0. Neither of these variables, x nor y, can be 0. And so that's what my restriction is stating. So there's your answer to this division problem. Okay, this is a little bit like your number 8. And let's just take a look. It says to multiply. Well, can we cancel anything first? Well, let's see. I can divide 3x squared into both of these. 3x squared into itself. 3x squared into 9x fourth is 3x squared. Going this way, I can divide y into both of these. Y into itself is just 1, 7 times 1. Y into itself again, 4 times 1, which is 4. Okay, multiply straight across. 1 times 7 is 7. 4 times 3x squared is 12x squared. And now I'm looking for restrictions, and don't forget, even though I've marked out this y, I need to consider it. I cannot let x nor y, neither x nor y can be 0. Those are my restrictions. So that's my answer to that example. Okay, so here's some more multiplication. Then I've got one division example. And once again, before you start multiplying, you need to factor everything you can. So this lesson is going to give you a really good exercise in factoring. All right, factoring this numerator. I know that if these are going to be linear binomials, then they each have to contain x to the first. 3x times x is 3x squared. So now I'm going to put the factors of -2 so that I come up with positive 5x in the middle. Well, this would give me positive 6x when I do FOIL. And I'm going to have a -1 over here. So positive 6x minus 1x is positive 5x. Okay, so that's the factoring of that numerator. The denominator doesn't factor. This other numerator is the difference between two perfect squares. And hopefully you remember how those factor. And now let's do this other denominator. And just for sake of review, we looked at the box method again. Whenever the number in front of x squared is greater than 1, let's just review this little box method because it may come in handy for some of the tougher factoring problems. First of all, I know that both of the signs of my factoring have to be minus. Remember, minus in front of plus. So I wrote the first and the last terms across from each other. I'm going to multiply those together. And now I need the factors of 6x squared that add up to 7x, and that would be 6x and x. So now find your GCFs. The GCF of the top row is 3x. Bottom row is 1. This column would be x, and this column would be 2. So those numbers show us the factoring, 3x minus 1, x minus 2. All right. And now we're ready to see what we can cancel. So let's see. I notice these matching 3x minus 1 binomials. I notice I've got matching x minus 5 binomials. Don't see anything else that matches that can cancel, so whatever doesn't cancel becomes part of my answer. So my numerator is going to be x plus 2 times x plus 5. The denominator, all that's left is x minus 2. All right, so for restrictions, I just start looking at all the denominators, all the factors of each denominator. So in this first denominator, I cannot let x become 5. Here, I cannot let x be 1/3. And if you're not sure why, we'll just let 3x minus 1 equals 0 and solve for x, and you'll see that you get 1/3. And here, I cannot let x be 2. If I let x be any of these three numbers, then I'm going to get 0 in a denominator, which is undefined. Okay, so this would be my final answer to this example. Okay, I think I just got one more. Here's a division problem. So first thing we'll do is start factoring. Numerator here would factor as y plus 4 times y plus 1. Okay. The denominator below that would be y plus 7 times y minus 7. Okay, now remember, for division, we're going to change this to multiply, but then we have to flip this fraction over, write the reciprocal. Okay, so this denominator here, I'm going to factor it and put it as the numerator. Okay, so hopefully you can see that this is y plus 7 times y plus 2. Okay, notice I just flipped it over. And this numerator, when it's flipped over, becomes the denominator, and we'll factor that. 2y times y. And now we're going to do the factors of negative 12. That will be minus or plus 4 here, minus 3 here. Okay, so just do a quick FOIL check to make sure that those are factored correctly. Plus 8y minus 3y is plus 5y, and then minus 12. Okay, now let's start canceling everything possible. Notice we can cancel here, 1 to 1, y plus 7s. The y plus 4s here can cancel. Anything else? I don't see anything else, so whatever doesn't cancel will be shown as our answer. So we got y plus 1 times y plus 2 in the numerator, and in the denominator we have y minus 7 times 2y minus 3. Okay, now here is where finding restrictions for division for some people gets a little tricky. You just have to remember that when the problem was originally written, y squared plus 9y plus 14 was the denominator. But when we rewrote it using multiplication, we switched to this as a denominator. Okay, so depending on how the problem is written, either of these would be a denominator. So for that reason, when you start looking for restrictions for division, you really have to look everywhere I've circled. Now that's different than multiplication. So let's just look at all the factors. I cannot let y be negative 7 or positive 7. I cannot let y be 3 over 2 here. Cannot let y be negative 4. And once again, I've already taken care of negative 7, but I also have to consider here, I cannot let y be negative 2. So that's my complete answer to this example. And I just wanted to point out again, for division, you actually have to include both parts of this fraction when you start looking for restrictions, because at some point, whether it's division or multiplication, they both could be written as denominators. Okay, so I believe that's it. And you have the assignment. You're doing all 1 through 20 on pages 501, 502. So you can let me know if you have any questions.